Now let's shift gears with systems and talk about some inequalities, systems of inequalities, because sometimes, like we know with inequalities, an equation just doesn't fit, because there's more than one possibility. So let's take a look at a few to kind of get us thinking through this. Mike's Toy Truck Company manufactures two models of toy trucks, standard model and deluxe model. Each standard model requires 2 hours for painting and 3 hours for detail work. Each deluxe model requires 3 hours of painting and 4 hours of detail work. 2 painters and 3 detail workers are employed by the company, and each works 40 hours per week. Find the possible number of trucks that they can build per week. So, we've got to figure out how we can get this to work, right? So, we've got 2 painters, 3 detail workers. They each work 40. So for painters, we've got 80 hours total, right? The detail workers, there's 3 of them, so 120 hours. So now we're looking at this. So we've got the standard model, so we'll call that S for standard, right? And we've got let's see. No, we want to think through this in terms of, because it doesn't matter if we're making a standard or deluxe model. What matters is time. 2 hours for painting and 3 hours for painting, and then 3 hours of detail work and 4 hours of detail work. Well, the painters are going to be with the work. So yeah, standard model we wanted S, and deluxe model we'll call D, right? So if we're thinking through this, for the standard model we have 2 hours, so 2 times S for each one. Okay, plus if we're thinking through the deluxe models, that would be 3 hours times D. Now we only have 80 hours in a week with painters. So for that painting, that's going to have to be less than or equal to 80 hours. Okay, that's one inequality. Erase that out of our way. Okay, then for the detail, we've got 120 hours that it can't be bigger than. And for the standard model, it's 3 hours, so 3 times S, plus for the deluxe, it's 4, so 4D. It has to be less than or equal to 120, because those hours matter. Okay, so now we can graph these. So there's a few different ways we can do that. Our favorite is probably to turn it into slope-intercept form, right? So let's call D the y-axis, S the x-axis. So I'd subtract 2S to get 3D is less than or equal to negative 2S plus 80 divided by 3. And we'd get D is less than or equal to negative 2/3 S plus 80 divided by 3. That's not going to be a nice number, is it? I don't like it when they're not nice for me. So, that would be 26.6666667. Okay, repeated sixes basically. So that's not going to be the easiest, so let's not do it that way. Okay, I know we normally do it that way, but let me show you how we can use the x and y intercepts to help us figure this out. Which it won't really help with the y-intercept, but for the x-intercept it would. Okay, and it would help us graph it a little better. So, what if I only made, oops, I still have my eraser on. What if I only made the standard, painted the standard? Well, we have 80 hours, it takes 2 hours per one, so 80 divided by 2 would give us 40. So let's call this 40. So I think we're going to have to count by 4s. Because there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that would be 20. So we'll count by 2s. And that would be, yeah. So 40 would be right there. 20 would be right there. There's 10. Sorry about that. So there's my scale. I'm counting by 2s. Okay. So at 40, we would have just standard. Well, if we just had deluxe, that would have been the 26 2/3. So a little past 26. So let's count off those ones as well. Alright, so we got our scale down there too. So it's 80 divided by 3 would be 26 2/3. So we'd graph that one. So 22, 4, 6 2/3. So it'd be right about there. Okay. Now this is going to be the tricky part. It's figuring out, because it could be equal to it, and we know it's going to be somewhere less than, right? Okay, because we can't go over that line. So now we do it for the next one. So if we only made standard, I'd go 120 divided by 3, which would give me 40 again, right? So I know that's going to be 40. But what if we did deluxe? Well, 120 divided by 4 would give us 30. So it'd be 30. It would be up there. So then we try to draw a straight line here. Okay. So then we would shade that one. And what we're looking for is the part where both of them are shaded. And both of them are shaded from here to wherever this line intersects down. Okay. Something like that. So that's the number of deluxe and standard trucks we can, models of toy trucks we can make. Okay, so let's take a look at this and see kind of, we graph it with technology, get an idea of what it would look like for us. So when we graph it with technology, we kind of see that same idea. So this blue area is the area where it would work for the painting or the detailing, but not the painting. So we'd have to pick numbers that fit in these points for how many trucks of each type we could make. Okay? So there we go. Alright, let's take a look at the next one. Nola's Nuts has 90 pounds of cashews and 120 pounds of peanuts available. These are to be mixed in 12-ounce packages as follows. Mix Yum contains 8 ounces of peanuts and 4 ounces of cashews, and Mix Tasty contains 6 ounces of peanuts and 6 ounces of cashews. Okay, so we're dealing here with different packaging and how many cashews and peanuts they put into them. So we've got two, right? Mix Yum and Mix Tasty. I'm going to change that to red. Okay, so we've got 8 ounces of peanuts and 4 ounces of cashews, or 6 ounces of peanuts and 6 ounces of cashews. And we've got 90 pounds and 120 pounds available. Okay, so we're trying to figure out what different types of mixes we can have here. So the way we're thinking through this one, okay, it's kind of a little different than you would think. Okay, but we're saying, okay, we know we have 90 pounds of cashews. Okay, so which, if we times that by 16, that would give us 1,440 ounces of cashews to put into 12-ounce bags. Okay, so we know that we can't use more than that. Well, Mix Yum, we'll call that one X, and we'll call Mix Tasty Y. So they have 4 ounces of cashews in Mix Yum, so I'd go 4 times X. And I'm going to add to that our Mix Tasty cashews, which is 6, so 6Y. Because we can't go over the amount of cashews we have, okay? That's why we've got to pay attention to that. So in the same way, we'd find out what 120 is, so 120 times 16. So we have 1,920. And that's got to be, the amounts we use have to be less than that. So in Mix Yum, we've got 8 ounces, so I'd go 8x, plus in Mix Tasty, we've got 6 ounces, so it'd be 6y. Okay, so now we are going to graph these to figure out where things are connected. Okay, so once again, we can try to turn this into slope-intercept form. And we'll be able to do that. It's just going to be really big numbers. Okay, so this first one, we'd subtract the 4x. Okay, so we'd have 6y is less than or equal to negative 4x plus 1,440 divided by 6. We'd get y is less than or equal to 4 over 6. We reduce to 2/3. So negative 2/3 x. And then divide that by 6 and we get 240. Okay. Our second one, we divide that by, or not divide, well, subtract 8x from that. We'd end up with 6y is less than or equal to 8x, negative 8x plus 1920. Divide by 6. We get y is less than or equal to negative 4/3 x plus 1920 divided by 6 is 320. So we've got the two equations that we can graph. Now the problem is our numbers are pretty big. So we'd go up to the y-intercepts, okay, and graph them and go from there. Okay, I'm going to use some technology so we can actually see it better because I can't make graphs that well that are that big. So we graph both of these and we see what we've got. Now remember, our x stood for the, what did they stand for? The cashews, right? And our y stood for the peanuts. So these would be cashews and peanuts. Okay, so we can see our y-intercepts, right? 240, 320, and then we go down and we see our x-intercepts, and we see that point where they intersect. That's the point where they, it changes. So if we're looking at the area that we can, it's going to fit into this area, right? This is the amount of bags we can use of each one, of each type of, the number of cashews and peanuts we can use that won't go over, that'll fit within our constraints. So notice it's where they overlap. And that's the idea with the systems of inequalities. Because you're shading, you're looking for that overlapping piece. Okay? So let's see how we do it on some more simple equations. Okay? So we take a look at these and we graph each inequality. So slope-intercept form. So I start at -1, go up 4, to the right 3, or down 4, to the left 3. It's got an equal to, so I know it's a solid line. Then I have to decide where to shade. So I pick my test point 0, 0. 0 for y, 0 for x. That cancels out. Is 0 less than or equal to -1? Nope, so I'd shade this side. Then on my second one, I graph it. Positive 2, slope of up 1 to the right 3. Now where they intersect is great, but it really doesn't help us. It's not what we need to know. It's also got the equal to, so I draw a solid line. Now where do we shade? Pick your test point 0, 0. 0 for y, 0 for x. Is 0 greater than or equal to 2? Nope, so I shade this side. So now what we're looking for is where the shaded parts overlap. That's our answer. Okay? Where just is the green, it works for this equation, inequality. Where it's just purple, it works for just this inequality. Where they overlap is what we're looking for because it works for both of them. And where nothing's happening, it doesn't work for any of them. Okay, so let's take a look at number 4. Same idea. Plus 2, so go up 2. It's 5x. So up 5 and to the right 1, or down 5 to the left 1. Equal to, so I draw my line. Then I do the next one. Plus 1, so I start at plus 1. Down 5 to the left 1. It's dashed. So I've got both my lines. They're parallel, right? So now I got to decide where to shade. Okay? So let's pick the point 0, 1, because it's a bit further away for the other one. So 0 for y, 1 for x. So 5 plus 1 is 6. Is 0 greater than 6? Yeah, so I shade this side. Okay, for my first one, I'll use that same point, 0, 1. 0 is less than or equal to 5 times 1 plus 2. Okay, that's definitely going to be bigger too. So they're both shaded, so where do they overlap? Well, basically right over here. That's the double shaded that's where our answer lies. So that's all we're doing with these. We're graphing them both, deciding where their answer lies. So if we look at this one, x is greater than 2. So I go to positive 2, draw my dashed line because there's no equal to. It's a vertical line. And x is bigger than that, so I'm going to shade to the right because those are where my bigger numbers are. For the other one, go down to negative 2. Okay, then up 1 to the right 2, up 1 to the right 2, or down 1 to the left 2. It's got the equal to, so I draw my solid line. Where do I shade? Pick 0, 0, 0 for y, 0 for x. That becomes 0 minus 2 is negative 2. Is 0 greater than or equal to negative 2? It is, so I shade this side above. Where do they overlap? Right there. That's my answer. Where the sides overlap is where we have our answer. So that's all we do. Okay, number 6. Start at positive 1, down 4, to the right 3, or up 4, to the left 3, because it's negative. Doesn't have the equal to, so it's a dash. Well, that should have been a dashed line. Okay, pick the point 0, 0, 0 for y, 0 for x. That would cancel out. Is 0 less than 1? Yes. So we shade that side. Graph my other one down to negative 2, down 4, to the left 3, or up 4, or whoops, down and to the right, or up 4, to the left 3. This one's solid because it's equal to. Shade, test that point 0, 0. 0 for that would eliminate. 0 for that. Is 0 less than or equal to negative 2? Nope, it is not. So we shade the opposite side. So where do they overlap? Right here. That's your answer, where they overlap. That's what we're looking for. Okay? So that's what we do on all of these. It's just that same process over and over. So positive 2, going down 1 to the right 3, or up 1 to the left 3 because it's negative. It's got an equal to. Draw my line. Pick my test point 0, 0, 0 for y, 0 for x. So 0 less than or equal to 2. Yes, it is, so I shade that side. Okay, then my second one, start at negative 3, up 4, to the right 3. It is also a solid line because it's got the equal to. Pick your test point 0, 0, 0 and 0. That eliminates, so is 0 greater than or equal to negative 3? It is. So we shade the side with 0. And once again, where does it overlap? That area. That's my answer. Okay, so that's all we're doing here. So, keep on going. Negative 2, going down 3, to the right 2, or up 3, to the left 2. Okay, it's dashed because there's no equal to. So draw my line, pick my test point 0, 0. Notice, with the slope-intercept, I'm going to have 0 is less than, because y becomes 0. My slope is always going to disappear, so I'm left with my y-intercept. Is 0 less than negative 2? No. So we shade down here. Positive 3, down 3, to the right 2. It's also dashed. Okay, it says y is greater, so pick that test point 0, 0. 0 for y, so y is greater than. That eliminates 3. That is not true, so we shade out here. So are they ever going to overlap? No, so this is basically like solutions. Okay, because they never overlap. There's no place where they're both shaded. Alright, so let's keep doing these. So, positive 3, negative 1/2, down 1 to the right 2, or up 1 to the left 2. It's got no equal to, so we draw our dashed line. Pick our test point 0, 0, so 0 for y, 0 for x, so is 0 greater than 3? Nope. Shade that side. Start at negative 1, go up 3, to the right 2. Remember, it's important to know where they intersect, but that's not part of our answer. It's got the equal to, so it's solid. Okay, now let's draw that better. So pick our test point, 0, 0, 0 for y. So 0 less than or equal to 0 for x eliminates that. Minus 1, nope. So we shade over here and we can see where they overlap, right? Right in that zone. So remember, where they overlap is where it's an answer for both of them. Any of the points I pick over here will work in both of these. If I pick points over here, it won't work in this one, it will work in this one. If I pick points in the orange, it won't work for the bottom, it will work for the top. If I pick points over here, it won't work for either of them. Okay, that's kind of the 4 areas that we're talking about. Alright. So, next one. Positive 2. Go up to 2, down 5, to the right 2. It is a solid line. Draw the solid line. Second one, negative 2. Go down 1 to the right 2, or up 1 to the left 2. It's also a solid line because it's got the equal to. Now where do we shade on either one? Well, let's pick 0, 0 as our point, and let's do them at the same time. Okay, remember that's gray, that's brown. So 0 for y's, 0 for x's, those eliminate. So I get is 0 less than or equal to 2, and is 0 greater than or equal to negative 2. Yes, it is less than 2, so the gray we shade towards the 0. Yes, it is also greater than negative 2, so for the brown we shade above the 0. Where do they both overlap? Right in that slice right there. That's our answer. Okay, number 11, same idea. Now we're dealing with standard form equations, right? So we've got to adjust those. So subtract x, we get y is greater than negative x minus 3. Go down to negative 3, down 1 to the right one because it's negative x. This is not an equal to, so it's dashed. 0 and 0, 0 for x, 0 for y, add them together is 0 greater than negative 3. Yep, so I shade up there. Now gray, we'd subtract 3x to get negative 2y is less than or equal to negative 3x minus 4. Divide by negative 2, what happens when we divide by negative? We get y is greater than and equal to instead of less than or equal to. Negative over negative, so we get 3 over 2x, negative over negative, plus 2. So up to positive 2, up 3 to the right 2, or down 3 to the left 2. It's a solid line. Pick our test point 0, 0. 0 here would give us 0. Is 0 less than negative 4? Nope. So we shade the opposite side, which is here. So where do they overlap? Right in this area. Alright, those two colors don't work too well together, do they? Okay. So same with this one. Subtract 4x. So I get y is less than or equal to negative 4x minus 1. So slope, y-intercept negative 1, slope of down 4 to the right 1, or up 4 to the left 1. It's got the line, so we draw a solid line. This one we'd subtract x, giving us y is greater than or equal to negative x plus 2. So up to positive 2, then down 1 to the right 1. It also has an equal to, or up 1 to the left, so we know it's a solid line. Okay, so now our test point, right? And you can use those new equations, or you can use the old ones. So this one's kind of close to 0, 0, so why don't we try negative 1, 0. So 4 times negative 1 plus 0 is less than or equal to negative 1. 4 times negative 1 is negative 4 plus 0 is negative 4. Is it less than negative 1? Yep, so shade that side. Orange, we can pick 0, 0. 0 for x, 0 for y. Is 0 greater than or equal to 2? Nope, so I shade here. Where do they overlap? That itty bitty little slice right there. Alright, last two, same idea. Okay, same. So we subtract x, giving me 3y is less than or equal to negative x minus 3. Divide by 3. We get y is less than or equal to negative 1/3 x minus 1. Start at minus 1, down 1 to the right 3, or up 1 to the left 3. It's got the equal to, so solid line. Check the 0, 0. If I do zeros in the standard form, the zeros cancel out. We're left, is 0 less than negative 3? Nope. So shade down the opposite side. Second one, we'd subtract 4x, giving us 3y is greater than negative 4x plus 6. Divide by 3. We get y is greater than negative 4 thirds x plus 2. Up to positive 2, down 4, to the right 3. It is dotted because it does not have an equal to. Pick the test point 0, 0. So I can try it here, right? 4 times 0 is 0. 3 times 0 is 0. 0 plus 0 is 0 greater than 6. Nope. So we shade out here. Where do they overlap? Right there, in that area. That's the solution to both of them. Alright, now last one. Okay, so subtract 2x. Negative y is greater than negative 2x minus 3 when we rewrite it. Divide everything by negative 1. So we get y, we get positive 2x, positive 3, but we change the inequality. So up to 3. Up 2 to the right 1, or down 2 to the left 1. Keep going. No equal to there, so dotted line. Pick our test point 0, 0. 0 for x and y. Is 0 less than 3? Yes, it is, so shade that side. Then we do the next equation. Subtract 4x. So we get y is greater than or equal to negative 4x minus 3. So down to minus 3. Then it's like down 4 and to the right 1, or up 4 to the left 1. Got the equal to, so we draw our solid line. Pick our test point 0, 0. 4 times 0 is 0. Y is 0. Is 0 greater than or equal to negative 3? It is, so we shade that side. So where do they overlap? Right here. That's our answer. And that's how we graph a system of inequalities. Graph each inequality, find where they intersect. And as always, remember this. Okay? All the points over here on this graph are a solution to both of these equations. Meaning, if I plugged any of those points in, this would work, and this would work. Okay? That's the solution to the inequality. If I just wanted a solution to one of them, like the top one, then I'd have to pick points in this zone. If I wanted a solution that was just a solution to the bottom, I'd pick points in this zone. If I wanted points that were no solutions, I would pick points in that last zone. So, no answers, one answer, both answers.